طيب بسم الله الرحمن الرحيم. As we discussed last time, subnetting is all about network segmentation. The advantages of subnetting is just to reduce. The advantages of subnetting is mainly to reduce the size of the broadcast domains, because the large broadcast domains degrade the performance, because the broadcast traffic will have to flow through many large number of devices, and all the devices they will have to consume and process the traffic, which degrades the performance. Also, there is a risk of security attack, that if one of the machines is compromised, you have a very large broadcast domain that this machine may affect other machines in the same LAN. However, network segmentation is not used to save addresses. As we said before, it actually makes you lose addresses, because in each subnet you will have to lose 2 addresses. So having said that, well, once we come to the conclusion that we need to subnet, now we need to take into consideration many factors. One of them is how the organization or how the building is structured, how many devices exist in the same geographical area, or they need to interact, or they need to access resources from each other. And also, what are the nature of the devices used in each location? For example, if you have like printers, faxes, servers, like FTP servers, telnet servers, these types of devices, naturally, they need to be accessible from outside, in which case we need to assign static IP addresses to these types of devices. Other devices like routers, they need to be assigned addresses to the interfaces, and typically these addresses are either the first or the last usable host address in this subnet range, right? Other than that, all other machines are typically clients, or they are normal user machines that can move from one location to another, in which case typically what we do is that we assign IP addresses dynamically to these hosts, because they don't exist permanently in that location, and they don't necessarily need to be accessible from outside. So the way that we design these subnets is that typically we have the IP address, as we said before, and the IP address is actually divided into 2 parts. There is the network part, and there is the host part, right? And we said that this boundary can move left or right, okay, based on the subnet mask. So using the concept of subnet mask, we can have this boundary move left and right as we find appropriate. So now with the concept of subnetting, we need to divide this network, which has one network address, into different subnets. So we need to subdivide this network into different subnets. The way we do that is by borrowing some bits from the host part. So we call this the subnet number. So this subnet number will vary for each subnetwork, and based on changing this subnetwork number, the whole network address will change. However, the subnet mask, remember that the subnet mask will be common for all these subnets, right? So the subnet mask will be common for all the subnets. So instead of subnet mask, for example, /16, so we take another 8 bits, okay, from the host part, which is also 16 bits. We take another 8 bits to assign it to the to subnet number, in which case the /16 network becomes a /24 network, which means that the subnet mask will be common for all these subnets. And then the difference between the two is 8 bits, which means that you can divide your network into 2 to the power 8 different subnets. Okay? And each network or each subnetwork will have 2 to the power 8 minus 2 hosts. Okay? So that's typically how we subnetwork any large network. So The remaining part of the chapter is just to go through the different calculations, how we calculate the network address, how we calculate a subnet mask for a particular network, how we calculate the range of IP addresses, whether it's a range of valid host addresses, what is the first one, what is the last one, and what is the broadcast address for each subnetwork. Okay, so we need to go through these exercises. So the first one is just to calculate the network address in decimal for this host address, and the second one is just to calculate how many valid host addresses you can have in this network. And remember, if I tell you how many addresses exist in this network in general, I don't specify what type of address, in which case you need to calculate the number of all types of addresses, including network address, host address, broadcast address, all included. But if I ask you what is the number of valid host addresses, then you have to subtract 2. Okay? So we need to calculate these 2 values. Okay. So we just need to notice one simple thing, because I will get more complaints. The time is not enough and things like that.
Just extra 1 minute.
For the first exercise, Muhammad, we just need to notice one thing. First, if the change from 1s to 0s in the subnet mask is in this byte, so we need to focus. We know that we need to focus on this byte. Okay, first of all, this part is 0 and this part is the same, right? So we don't need to worry about those 2 parts. We just need to worry about this byte only. That's one thing. The other thing is that we need to notice that the subnet mask has 6 ones, and then only those 2 are zeros, right? Which means that we need to mask only those 2 bits, right? We mask only 2 bits. And these 2 bits, they happen to be 0, 1. So this is equivalent to the fact that you subtract 1 from this. Because the 2 bits that you need to mask happen to be 0, 1. If they are 1, 0, then you need to subtract 2. If they are 1, 1, you need to subtract 3, and so on. So this is actually, I don't need to go through any calculations while I calculate it. It's very, very straightforward. And of course, this will be 0, and this will be 10 to 30. So this will be the same, and on the right-hand side will be all zeros. Here also, I don't need to go through the representation in binary and all of this. I just need to know one piece of information: the number of bits for the host part, which is in that case 5, right? So 6. Okay, so the number of bits for the host part are 6. Therefore, the number of valid hosts is 2 to the power 6 minus 2, which is a 62. Okay. How much time did I take? 5-10 seconds?
That's not the full answer.
Doctor, from this information, can we calculate the subnets? How many subnets?
How many?
Subnets.
لا. How many? لا. If I want to ask you about how many subnets, خليك معايا يا شباب. If I want to ask you how many subnets, then I have to tell you that I have a network, for example, /16.
Yes.
And then the new subnet mask is /20, for example. So how many subnets do I have? Then you subtract 20 from the 16. 4 bits. 4 bits will give you how many subnets? 16. Okay. But in this question, I didn't ask you about that. So using the same concept, in 5 I want you to calculate the number of valid hosts for those 2 simple examples. And I want you to finish it in 5 seconds and tell me I finished.
Which question?
In 5 seconds. It doesn't take more than that.
I have finished. Yes, really.
So this one, from 3 bits, you can get 8 total addresses. So 2 to the power 3 minus 2, that's a 6. And for this one, if you have 4, 2 to the power 4 minus 2, that's a 14. And again, this is for valid host addresses. شوف هو مش مركز ازاي؟ هيجي في الامتحان يقول لي انت ما قلتش ان ده كذا. You blame no one but yourself. Okay. Okay. طيب. So this next one is a bit heavy, so you need to do some calculation. And again, try to do it without calculator, please. Yani just detach yourself from the calculator and try to do it without calculator. Just by simple observation. Okay? Next one. Asana, I forgot to record this, but I'm just trying to capture the screen. Okay. So again, very quickly, the calculation will be focused on this byte. Okay. So again, we need to calculate the network address. So the network address will be, Sulaiman. The network address will be to set all these bits to 0, right? When you set all these bits to 0, there will be only one, which is 32. So the network address here is 32. So again, the first usable host address is a 33. So now when we want to calculate the next network address, so you have 5 bits here. So the number of addresses will be 2 to the power 5, which is 32. Plus 32, that's a 64. So the broadcast address is 63, and the last usable address is 62. So this whole thing will be exactly the same. I don't have to calculate it.
معلش دكتور أخيرا بنقطة 64.
So again, 64, we have 5 bits for host, which means that the total number of addresses, including network, broadcast, everything, is 2 to the power 5, which is 32.
Yes.
Which means that if we have the network address 32, we need to add 32 to A to get to the next network address, which is 64. And then subtract 1 becomes broadcast, subtract 1 becomes the last host usable address. That's it. Okay? Any difficulty here? It's just straightforward. Okay. So next time we'll solve the exercise that Ghanem already solved.